Good morning, Doctor. We are the group from the section 2, and our group member consists of Tay Wei Jian, Guo Xu, and also me, Teoh Yee Xian. And so I'll start off by showing you the application of our assignment. I'll start by typing out this code to put up the output. Yeah, so this will be the main page of our assignment 3, and we will be able to choose an image, and this 5 image is the one that we're going to do. Yeah, so I will just maybe present to you few of them. Just first choose the one, and then there will be 3 menu pop up, and 2 of them is the image. The first image is the input image, and the second one is the output image. And the third menu is the adaptive threshold. And I have to mention that we using the adaptive threshold to do the assignment 3. So we have been having to change the value of the block size and also the C constants to get the desired output. Yeah, so after we change any of these, the output will be displayed over here. Like for example, I set to 11 and 33, and I apply adaptive threshold, then the output will be shown here. And if we not satisfied with the output, we can keep on drag and find the best value of them. Yeah. It seems that this could be the best one, so I will consider to save the output image, and I will just name the file name as the first image. Confirm. Yeah. Then the image will be saved. Maybe I will just show you for another one. Yeah, maybe like for the fourth image. Yeah, process is just same. We need to find the best value. Yeah, as this image is like quite different with the previous one, so the value will be different a bit. Yeah, we just gonna have to find out the best one. Seems like this could be the best desired output. Then we will just save the image, and this we will call this as default image. Yeah, and we will save successfully, and as we can see that the image will be saved over here, the fourth image and also the first image. So that's all about the application of our assignment 3. Thank you.
Good day, doctor. My name is Guo Xu. The next part is process flow. The process flow have 7 steps. The first step of the proposed solution is to acquire the input imaging that will be used to process the written text or picture contained in the imaging with unclear white background, and convert the imaging into an imaging with clear white background, and the written text or picture contained in input imaging is still returned in the output imaging. The second step is carrying the input imaging into grayscaler to use the imaging process used to extract the written text or picture. The third step is applying adaptive threshold on grayscaler imaging, where the threshold value used is the meaning of neighborhood area, with max value is set to 255. Threshold type is using inverted bandwidth to make the background black and the foreground white, and some parameters determined by the user, which are the sets of neighborhood used to calculate the threshold value, and the C value is constant used in adaptive threshold. The inserted bandwidth is used to apply the bandwidth on the operation used later with the original imaging to obtain black. The color information of foreground. The next step is to cover the threshold imaging from gray to the colored before applying the bandwidth and opposition to retire the color information of the foreground after the bandwidth on opposition end. The foreground will have the original color with the original input imaging, but the background will still in black color. Therefore, the black area will be covered to white color setting. The value for pixel of the background to 255 and the output imaging will be foreground with the previous color or with the clear white background. That's all for our process flow. The next, please my partner continue.
The next part is the code of the application. So the first class is the main patch class. The initialization function is the calling to create the window. And then the main patch function is used to specify the geometry and the title of the window. And then we also create the text and then also the label and prompts and apply it on the window. And then we also provide a button for the user to choose the image to click on and open the file explorer. And then the open image function is used to open the file explorer and then allow the users to select the image from the file explorer. And then after the file is selected, we will create a new input patch window. And then for the class input patch, the initialization is similar to the main patch class. And then we have the setter and getter of the image variable, and also the setter and getter for the segmented variable. The image variable is used to record the original image, and then the segmented is used to record the output image. In the display input function, we specify the two windows, which are input window and output window. And then first we initialize the segmented and the image variable with the file reader from the file opener. And then we display the window in the and we will display the window of the input window and output window. And then display the initialized image and segmented in the input window and output window. We also specify the geometry and title of the input patch window. In the input patch window, we have two slider, which is called the B size and the C. The B size is related to the size of the neighborhood used to calculate the mean used in the adaptive thresholding. And the second one is the C constant, which is also used in the adaptive thresholding. For the size of the neighborhood, the slider is set minimum to 3, and then the maximum is 100. And the resolution is set to 2 because the size of the neighborhood used cannot be divided by 2. So it must be the odd number and cannot be an even number. And we also provide a confirm button here, and in GUI it is called the apply adaptive threshold button. This one is allow the user to click on, and then by using the current B size and C constant value in the slider and applying the adaptive threshold on the inputted image. And we also provide a save button for the users to click on and save the output image. And at initial, the save button is disabled because the adaptive threshold is not yet applied on the original image yet. And the next function is the save window function. And we generated a new save window and then setting the geometry and the title of the newly generated window. And then we also give the label and the field for the users to fill in the file name of the output image. So in here, the user can input any names they want for the outputted image. And then we provide a button for the users to confirm the file name they want to use, and also call the step image function. The step image function is receiving the parameter of the TK window, which is the step window itself, to display this window later, and also the file name used to write the file into the computer. And the file name will be appended with the extension, which is the .png file. And then we use the cv.armWrite to output a file, the segmented file. And if the image is successfully saved, there will be a message box appear and notify the user. And else, if the image is still saved, they will also have an error message. And then all the windows will be displayed except for the main page. The next function is the threshold function. And we take 3 parameters here, which is the threshold. In here is the C constant. And then the window is the upper window. And the B size is the size of the neighborhood used to calculate the mean. So first of all, the original image, we convert the color to grayscale. And then next we applying the adaptive threshold on the converted image. And then we set the max value to 255. And by using adaptive threshold by min. And then we use the threshold type is the inverted binary one. And then the size of the neighborhood used, which depends on the user's input, and also the C constant also depends on the input by the user. And after we applying the adaptive threshold on the converted color image, we convert back the image from grayscale to BGR. And then we apply the bitwise AND operation on the converted color one. And after applying the threshold one with the original image to retrieve back the color information of the segmented area. And because we are applying the adaptive threshold here, so the foreground will be completely white and the background will be completely black. In our output image, we want the background to have a completely white image. So we use this line here to convert back all the black area into white area. And then after we doing so, we will display the output on the output window. And then we will enable the set button here, and to allow the users to save the image in the computer. And then we have the main function here, which is calling the main page class, and also calling the main page function to generate the main page window. And then this is all from us. Thank you.